Okay guys, so today we're going to talk about Wednesday's lesson, just going on from logarithms. Don't forget the packet's due Friday at the beginning of class, so make sure you're working on it and your Delta Math assignments. So I will collect the packet and only Friday at the beginning of class, only. Alright, so let's go on to Wednesdays. Okay, so for Wednesday, we are going to be expanding logarithms. So I'm gonna kind of talk about really quick like the rules. So exponential rule, I'm gonna talk about it on a separate sheet so you kind of get an example. So an exponential rule means like if I tell you 2 to the third power times 2 to the fourth power, what's a simpler way to write that? So 2 to the third power means 2 times 2 times 2, and 2 to the fourth means 2 times 2 times 2 times 2. And they are multiplying. So an easier way, instead of doing 2 to the third times 2 to the fourth, you can just say 2 to the seventh, right? Because there's 7. 1, 2, 3, 4, 5, 6, 7. So the 2 is multiplying 7 times. So really what happened to the exponents? They added. Okay, they added. It's 2 and then 3 plus 4. So then it turned into 2 to the seventh. And that only works because they both have a base of 2. So it's not going to work if you do 2 to the third times 3 to the sixth. You can't add them and make 9. You only add them if the base is the same. So that's the first rule. You could have done the example here, but I'm going to do it here with just variables. So if we have a base, let's say I have b, and that means it can be any number, and then it's raised to an exponent, and then we're going to multiply it by another base, the same base, to a different exponent. Then the rule is that it has the same base. So just like in the problem I did, right? 2 to the third and 2 to the fourth. So they're both 2's, but they have different exponents. Well, you can add m plus n. Okay, so now let's talk about how that works with the logarithm. With the log, if you have a log and it has a base, so we're going to call it b still. So the base, if you are multiplying two things, m times n, then it can change to addition, just like an exponent. So it's going to separate. Okay, they're going to separate into two adding logarithms. It's going to be log, still base b of m, plus log base b of n. And you'll kind of see an example of it when we get to the bottom. Okay, next one, quotient rule. So if we are on the quotient rule, that's division. So for exponents, okay, another example. So let's do another example. So for exponents, if I have 2 to the third, you know what, I'll do a different one. 5 to the fourth power divided by 5 to the second power. What that means is you're doing 5 times 5 times 5 times 5, and on the bottom 5 times 5. Okay, what happens when we divide? If you have the same number over the same number, it cancels out to 1. So that's one pair that canceled. Here, 5 and 5 cancel. So now what do we really have left? We have nothing left on the bottom, and we only have 2 5s at the top. So the answer is 5 squared. And how did that really work? What happens is they subtract when you're dividing. So another example, like 6 to the fifth power divided by 6 to the second power. So 6 times 6 times 6, 5 times on the top, and then on the bottom I have 6 times 6. So these cancel to 1. These cancel to 1. How many do we have left? At the top, we only have 3. And it's because 5 subtracts 2, and it makes 3. So that's kind of how that exponential rule works with when you're dividing. So we're going to write it here with just variables. So if you have b to the m over b to the n, then it's the same thing as b of m minus n. You subtract the top number minus the bottom one. And with logarithms, it is going to separate into subtracting. So if I have log base b of m over n then it's going to be the same thing of log base b of m minus log base b of n. And the last one, the power rule, the exponent rule. Okay, so example, if you have 2 to the third and then you have an exponent squared, that means that this thing in parentheses has to multiply 2 times. So it's the same thing as 2 to the third times 2 to the third. So what does that mean? It means you have, if I have 2 to the third, that means I have 3 2's. 2 to the third is another 3 2's. So how many is that all together? It's to the 6. And remember, this goes back to this rule because you could have just added 3 plus 3 because they have the same base and they have exponents, so you just add them together. Really what's happening here is these two are multiplying. When you have an exponent, they multiply. 3 times 2, you would have gotten 6. I'll show you one more. So like 5 to the 4th to the 3rd power, right? So the answer already, if you kind of got the idea of what happens, is these two multiply. It is going to be 5 to the 12. It's going to be 5 12s multiplying together. But if you wanted to show work, okay, so how does that work? It means that this parentheses has to be there 3 times. So I have 5 to the 4th times 5 to the 4th times 5 to the 4th. Okay, 5 to the 4th to the 3rd power means this, what's inside, is 3 times. And then here, 5 to the 4 means you have 4 5s. And then I have another 4 5s. And then I have another 4 5s. So this one has 5 5 5 4 times. This one has 5 5 5 5 4 times. This one has 5 5 5 5 4 times. So if you count them up together, 1 2 3 4 5 6 7 8 9 10 11 12, you get 12. Right? You have 5 multiplying 12 times. So it's little shortcuts that we can take. So you kind of got to work with them and get used to them. So the power rule in this one is if we have a base, and let's say we have m, and then we bring it to another exponent, then you just multiply those, okay? It's kind of like distribution. So they multiply. So it turns into b of m times n. They multiply together. With logs, it kind of is a little bit different. With logarithms, if I have a log base b of m, and then it's raised to a different exponent, so I'm just going to use like k this time, then what happens is the exponent actually goes to the beginning of the log. It goes to the beginning. So the way that we would write it is k log, because it's multiplying, base b of m. Okay, hopefully that makes sense. If it doesn't, just come back to the rules a lot, and we're gonna kind of go over the examples, and I'll kind of show you that you can check your work on Desmos. I don't have a calculator. If not, I'd show you on the calculator. But okay, so here, these two are multiplying, right? The logs are multiplying, so we're at the product rule, and we're gonna separate it into two adding logarithms. We are expanding. What that means, expand means make it bigger, make it longer. So this log is short, I want to make it larger. So all you're doing is, because we have two pieces that are multiplying, just like the m and n, they each get their own log. So here I'm going to have log of 6 plus log of 11. And that's the answer. That's how it expands. It gets bigger, with which they basically have their own log. And if it's multiplying, it changes to addition. Right? If they're multiplying together with one log, they're together in one log, you can separate them as two. Okay, if you want to check your work to double check that you're doing all this right, I am going to pull up Desmos. Okay, I'm going to pull up Desmos. And then when you guys have Desmos on your computer, you go to functions right here, and you're going to come down. I think maybe I missed it. Oh, there it is. Okay, we use log and this other log. I'm gonna use this one right now, just log of 6 times 11. Okay, that's the answer we're looking for, 1.81. So now let's check, did we get the same answer when we write them separately? So log, you can even spell it with your keyboard, log of 6 plus, I can spell it log of 11. And it's the same answer, right? You get the same answer if they were multiplying together in one log as if you separate them into two separate logs. And you're kind of just doing that. So here they're multiplying in one log, so we're gonna expand them. We're gonna make them have their own log, but they separate with addition, log of 5. And again, check your work. Just multiply them, type the original, log of 3 times 5, and then we're gonna do them separate. Log of 3 plus log of 5. Well, I didn't type that one right. Log of 5. And you can see that they're the exact same answer. They have one log multiplying together, two separate logs with addition. I might not show you how to check your work on all of them, but we are doing them right. Okay, for this one, it does have a base. You see the little number? So we are gonna separate them still. Log base 3 of 7 plus log base 3 of 4. It just means that you need to remember to put the base. If that one has base, they're still multiplying, so they change to addition. They have their own log with adding. And on the calculator, this will probably be maybe the last one I show you. Here you would have to go to functions. Okay, you do have to go to functions for sure for this one. And it is this log, the log that has a little a on the bottom, because we need to put a 3 there. And then inside we put 7 times 4. And then to check our work, did we separate them correctly? Was it supposed to have a plus sign? Again, go back, log base 3 of 7 plus log base 3 of 4. If you get the same decimal, you know you did it right. Here they have one log, here they have their own, and it is the same exact decimal on the calculator. Okay, so that's kind of how they work. So here they're multiplying, they're gonna separate into addition, but they both have a base of 4. 6 plus log base 4 of 7. Okay, check your answer on the computer. This one is division. What did we say division changes to? Division changes to subtraction. So even though they're in a log together dividing, they're gonna separate to subtraction. So it's gonna be log base 6 minus log of 11. Not base 6. Log of 6 minus log of 11. Okay, check your answer, type it into the calculator. Oh my, okay. Log of 6 divided by 11, and then you just check log of 6 minus log of 11. Same answer, negative 0.26. And then the rest for both of them. One log, two separate logs. Okay, log of 3 minus log of 5. They are dividing, so they separate into subtraction. Okay, division separates to subtraction. Multiplying separates to addition. This one, it has a base of 3, so make sure you write that. Log base 3 of 7 minus log base 3 of 4. Okay, they're dividing, but they separate to subtraction. And break log base 4 of 6 minus log base 4 of 7. So very similar to this one, right? But this one's subtracting because they were dividing, and this one's adding because they were multiplying. Okay, they're multiplying in here, so it's addition when you expand them, when you make them larger, when you give them their own log. And here they're dividing, so they change to subtraction. I would try to finish the rest of them. You can pause the video and finish the rest of it, and then you can come back and just double check your work. Log, here they have x and y. They're actually two separate letters multiplying. You just don't see the little dot. So it's log of x plus log of y. Here m and m are multiplying, two separate letters. They're multiplying, so it's log of m plus log of n. And then for homework, you guys have to finish the rest of this page and a Delta Math assignment. But if you don't need to watch the video, don't watch it anymore. Just go finish the work and then come back and check your answers. Log of x log base x of p plus log base x of q. They were multiplying, so now they're adding. Log of v of k plus log base v of t. Okay, they're multiplying, so now they're adding. This one's a little different, the exponents. Log of 4 plus, because they're multiplying, log of 10. But we don't actually put the 3 here. It's kind of like the rule where if it's an exponent, it goes to the front. It only goes to the front of this one, so I would move it from here to here. Okay, it only goes to the front of this one because the exponent's only on the 10. And that's what it would look like. Type in this problem into decimals just so you can see that that is how that works. Okay, let's check really quick. Log 4 times 10 to the third. Okay, we get 3.60, and then our answer was log of 4. 4 was on its own, plus 3 log of 10. Okay, same decimal, right? They had one log multiplying, now they're adding, and the exponent 3 goes to the front only of this log, not both. Sometimes it is on both, sometimes it's not. They're multiplying, so now they're adding. Now it's going to be log of 3 plus log of 5. Okay, the 5 had an exponent of y, it goes to the beginning, so it's going to be here. And this one had an x, so now it goes to the front. There. These you probably won't be able to check on the calculator, okay? The ones you can only check on the calculator is if they're all numerical numbers, right? So this one you can't check on the calculator, or this one, because it has a y and an x. Okay, do you guys see how the exponent is outside the parentheses? They actually both do get the exponent. There is a 5 on the 6 and the 11 because they actually have an exponent of 1. So 5 times 1 is 5. The 6 has an invisible exponent of 1, and so does the 11. So now they each have a 5. So now if they're dividing, it is going to change to subtraction. And they each had an exponent of 5, so the 5 goes to the beginning. So now you can cross it out here. So that would be my final answer. 5 log of 6 minus 5 log of 11. You can type this one into the calculator to check it. This one can go in the calculator because it's all numerical. This one can't, neither can that one. This one is dividing, so it's going to be subtraction, but only the exponent on the 2. So it's log of 2, and it has a 4, minus log of 5. And don't forget, the exponent moves to the beginning, so not there. Okay, check it on the calculator. Here, the 7 is outside. It's kind of outside of both, so they each get it, because they each have an exponent of 1. So 7 times 1 is 7. That one gets a 7, and then on the y, 7 times 1 is 7. So they each get an exponent of 7. So it's log of x to the 7 minus log of y to the 7. And the 7 has to go to the beginning. So it's not going to be here anymore. It's just at the front. So 7 log of x minus 7 log of y. Last one, they are dividing, so it is going to be subtraction. Log base c of m, okay, they have the base of c, minus log base c of p. Your homework is to finish all of these. So these I am not going to do. So these are the ones that I would check. And then you also have a delta math assignment.